and then Luke Radowski. And we'll be recording this, and as people come in, like I know Joe Friendly's going to be coming in later, he'll probably only get half of the Internet Skeptic's presentation, but he's already seen some of it on the internet when I traveled to Dayton, Ohio. So I'm going to start right now. So welcome everybody. My name is Paula Gloria, and I'm the host of the daily public access TV show called Farther Down the Rabbit Hole. And the Internet Skeptic that I'm going to present to you tonight was an answer to a prayer of mine. And that was to really understand the science behind global warming. I didn't want to take it on anybody's authority, whether it was or whether it wasn't so. I had a certain intuition based on a time when I was a charity director and I had money to try to help good causes, that I was terribly frightened about Y2K. I was actually in India at an ashram at that time. 3 days I wouldn't get out of my bed from December 30th until January 1st. And when January 1st came around and the end of civilization didn't happen, I felt really stunned. Now, most people didn't get so invested in what was happening because most people weren't in the position of being newly rich to try to help right the world's wrongs. But it was a trauma that lasted so deep in me that when I started to hear some of the behavior of people after they heard global warming topics, it brought up certain memories of mine that it wasn't a path I wanted to go down. Now, my feeling, and on my TV show, I always tried to leave on a positive note. I tried to reveal to people very deep knowledge, and knowledge that's certainly not covered by mainstream media. But I'm very, very careful to not overload or to try to encourage people not to be overloaded with information so that they become depressed and despair, or certainly think that there's not enough room on this planet for all of us, because that's something that I profoundly believe in, and that genocide in any way, shape, or form should never be a solution. So I want to thank Alan Steinfeld, because it was his email list that allowed 5,000 people to have the opportunity to know about this event. And the last I checked, about 600 people had opened it up, and about 100 had actually clicked through. That email is very rich, and the links are very rich to it. There's not only an after presentation discussion on the lawn of Dayton, Ohio, with a Yale scientist who went to school with George Bush Sr. and who I'm always engaging in conversation about the world situation. He's a Republican, but upon deep consideration, he profoundly believes that we should reconsider being in Iraq. So I think the important thing is that we keep our hearts and our minds open, and that we can keep working together as a community, and that if we have differences, these differences are going to make our ultimate understandings far more richer, more profound, and more effective in manifestation in the planet, which is what we want to do. We want to create new realities. We don't want to think about them. We don't want to worry about them, but have a feeling that through science and through the ability to critically use our faculties, we can have a life that's far richer and more rewarding for all of us than we have so far. So at this point, what I'm going to do is turn it over to Alan Steinfeld to talk a little bit about new realities. I've just said I'm the host of Farther Down the Rabbit Hole, which is dedicated to politics and spirituality. And now here's Alan from New Realities. Thank you.
Thank you. Thank you. Thanks, everybody, for coming, whoever did come. And I know that people tend to believe the authority, whoever the authority is. So if someone like Al Gore says there's global warming and there starts to become a momentum behind it, everyone starts to say, well, there's global warming. And I'm not saying there isn't. I'm just saying, let's look at everything. Let's question everything. It's obvious that the environment is being destroyed, that no one's going to question that pollution has affected the planet, has wiped out species, has destroyed forests, have have poisoned people in the city's water supply. Water being our most valuable resource is now threatened. There's so much to look at and question, but really we have to question all of it. Who's telling us what? And that is why I actually haven't seen Bob's presentation, but that's why I'm open to seeing what the Internet Skeptic actually does have to say. And then I'll make my decision, you know. I look at all realities and then decide which one makes the most sense to me from the position that I'm in. So who knows? I mean, maybe, as people have said, the whole solar system is heating up, and the Earth being part of that collective is just one, just another part of that, and that there's more factors than that we're aware of. So that's what I'm here to find out tonight, and then all of us will make our own decision, and I just say keep questioning everything people tell you, and let's form our own ideas, because that's the way things like alternative media will have a stronger voice. Otherwise, it's Al Gore on NBC telling us what's happening. Unless we have alternative media, we'll just have to accept Republicans or Democrats. There's no middle ground. So let's look for the middle ground and look for every place that's not black and white. So that's why I'm happy there's someone who's done their own thinking here and come up with his own conclusions, and that's why I'm here to come up with my own conclusions. So thank you all for coming, and Luke has a few words to say. Ooh. Let me put this mic on.
Thank you. Go ahead. Whatever.
Okay.
All right. Thank you, Paula, for having me. It really means a lot. My name is Luke Radowski. I'm one of the main organizers of the 9/11 Truth Movement here in New York City. Now, you probably ask yourself, 9/11 Truth Movement, what does it have to do with global warming? But when you really think about it, it has more similarities than you think. But if you're an American who really doesn't think, who just watches TV, when you first hear global warming, you just think Al Gore is a hero. You think eco-crimes. You think people are evil. You think of carbon emissions. And when you watch TV and when you think of 9/11, you hear of Islamic fundamentalism. You think of one man in a cave organizing everything. But with the internet, you're really able to think for free. You're really able to think independently, away from the mainstream corporate media. You're able to be more freer than you ever thought before. And you're able to use your mind. And you're able to hear more than one side of the story. And that's why it's really important. Even though there's not a lot of people here, there must be a lot of great people here. It's not the quantity, it's the quality of the people here. And again, a lot of stuff we don't understand. We watch TV, we hear one story. When we do our research, when we study, when we investigate certain topics, we really understand it to a bigger extent. Now, if you do your research, you understand the truth behind global warming, and how the global elite want to do a global tax on everybody. How the global elite want to put RFID chips in everybody's garbage cans. You understand how the global elite are using global warming as a way to get their power, as a way to get their new world order. Now, if you do your own research about 9/11, you also understand that the family members, rescue workers, which were affected by 9/11, have questions about 9/11, which were never answered by the Commission report. You understand that the Bush and Bin Ladens do business together with the Carlyle Group, with Robusto Oil. You understand that the government's covering up a lot of important information about 9/11. And that's what it's about. It's about hearing another side of the story and thinking for yourself independently, being smart. Because a lot of things we're not being told. You know, again, you look at 9/11, you think of George Bush being a hero. You think of global warming, you think of Al Gore being a hero. When in reality, left, right, it doesn't matter. Democrat, Republican, it doesn't matter. Liberal, conservative, it doesn't matter. It matters that you're an American and you care about this country and you care about the truth. That's what matters. That's what should care. And sadly, we're not getting that on the media. We're getting that on the internet. We're getting that from research, from thinking by ourselves, from researching it by ourselves. And that's what it's about. That's why this country is beautiful, because we get to think for ourselves. We get to express freedom of speech. Now, again, the internet is a beautiful, beautiful thing. We don't hear everything. Democrat, Republicans, they're really working together towards a new world order, towards more power and control, and they give us a fake choice. It doesn't matter if it's Gore or Bush. They all want power. They all, want to destroy, really, humanity, really, to be honest with you. And it's for us. And it's for the internet, and it's for movements like the 9/11 Truth Movement and the Truth Behind the Global Warming Movement to take this back. It's people's movements like this which are really going to take this country back and save this country from where we're going through right now. And I would like to thank everybody for coming out, even though it's not a lot of people. It's a lot of great people here, and that's what really matters. So thank you guys for coming out, and I just hope you guys enjoyed the program. There's free DVDs and flyers for everybody here. It's a free DVD unless you watch it and pass it on. So check out the free DVDs and flyers. Check out the website, wearechange.org. Thank you.
Thank you. So, like I say, it's all about having an open mind. Now I'm going to be turning this over to the Internet Skeptic, and he's going to make a presentation for about an hour, and then by that time I'm hoping there's a few people that are going to be coming late, and we're going to enter into the more dynamic part of the evening, which will be your questions, because the new media is you. So express it, and if any of you are shy, I know someone's coming later, we'll put them in the back where they won't be on the camera. Okay, well, we'll work that out later. So I'd like to introduce, do you want me to say your name? Okay, Bob Wagner is the Internet Skeptic. Thank you.
All right, well, thank you, Paul and Alan.
Thank you. Put that mic on. If you could just clip that onto you. You want to talk into here? Or this is a wireless here.
Oh, the wireless won't work because this thing up there is.
Oh, it will?
Yeah.
Okay.
Do you have a wired one?
No, that's okay. That will pick up that.
Okay, well, thank you for having me to the Big Apple. I just flew in today. I'm coming in from Columbus. And what I have done is, during my research, every time I'd look into the global warming claims or the theories, every time I looked into them, I would find that the conclusions that the scientists would reach wasn't necessarily supported by the data that they were providing. And the more and more I looked into it, the more and more I would find the situation. And so what I decided to do was I said, there's an interesting story to be told here. Put together a presentation. Now, I'm not going to tell you man's not causing global warming. But what I am going to do is I'm going to provide the research for you. And I've given the discs to Paula. And so if you're interested, you can take one of these discs. Everything that I'm going to do here, you can get off the internet. You can get on research reports. And you can go do your own research. So what I really want to do is I just want to provide you the information and provide you with an alternative story to consider when you're looking at the science and the theory behind global warming. That's why I have it up here. This is Albert Einstein, basically telling you that the mind works best when it's open. So what I'd ask you to do is forget everything you've been told. Okay, I know what you've been told. I've heard all the stories, and I've looked into them. But I want you to sit there and clear your mind for just 1 hour, listen to these arguments, listen to the science and look at the data, and then reach your own conclusion. I think you might find it interesting. One of the presentations that we did give, because when I looked into this, I thought the science was so bad that we titled a series of videos titled "Global Warming Does It Pass the Stink Test?" And we go down piece by piece and show them apart. We have those out on YouTube if you're interested. Okay. This is a quote from Dr. Fred Singer. He's the president of the Science and Environmental Policy Project, and he invited Al Gore to come to his presentation, and he gave his inconvenient truth. And this is the quote that Dr. Singer gave him. And Al Gore comes up to him and says, "Well, what do you think of the presentation?" He goes, "Well, your presentation is very persuasive to anyone that doesn't know the science." And I think that's what you're going to find. You can take the data and the graphics that they show, and they can make a great story for it, but if you understand science and understand what they're doing, you'll probably reach a different conclusion than what you're being told. This is what global warming is. Okay? Global warming is that we have greenhouse gases. The sunlight comes in, warms the earth, heats it up, and then at night it releases infrared radiation, and that infrared radiation is trapped by these greenhouse gases, what's called the greenhouse effect. Does anyone disagree with that theory? Because that's what we're going to address.
What are the greenhouse gases? We're
going to get to that. What does the big question though? What does most people think? What's the most significant greenhouse gas?
Water. CO2. Water.
I'm very glad to hear that. Most people, every time normally when I give this presentation, what do they say?
CO2.
CO2. Okay.
Teeny little piece.
Very good. Okay, well, you're right. And we're not talking a teeny little piece. We're talking a very teeny little piece. Okay? extremely teeny. Nitrogen makes up 78% of the atmosphere. Oxygen makes up 21%. The others, 1%. CO2 is 380 parts per million. That's 0.038% or 0.00038. That's all the CO2 there is in the atmosphere. And that's all of CO2. Man produces 5% of that, which is 0.00019 or 0.0019%. So man produces a sliver of a sliver. If you take a look here, this is the atmosphere. This is all of CO2. This is man-made CO2. It's so small you can't even get the slivers on it. That's all it is. But yet you're being told that this little sliver here that doesn't even graph is causing all this catastrophic problem. Now what it is it's all about absorption of infrared. That's all it is, trapping heat. Well, I heard someone say water vapor, and when I say what's the most significant greenhouse gas, they say water vapor. Why? Well, take a look here. This is a spectrum, absorption spectrum of the infrared spectrum. Down here you have the wavelength, and here you have the total absorption. This is the total atmosphere. This is the graph of the absorption of infrared. These are other greenhouse gases. Do any of these greenhouse gases look pretty similar to this one? Does that look a lot like that? Well, that's water vapor. As you can see, water vapor absorbs almost across the spectrum. Tremendous amount. This is CO2. These three little spikes of infrared absorption at 2.7, 4.3, and 15 microns is all that CO2 absorbs. But if you look carefully, I draw a perpendicular here, you'll see that the first at 2.7 overlaps with peak absorption at water vapor. So you can have no CO2 there and it wouldn't change at all because water vapor overwhelms it. Over here is essentially the only peak that's unique to CO2. And you can see it forms that little tiny bump. Then over here at 15, it has a little bit of a bump also created by CO2. But that's all global warming theory is. This little bump and this little bump. Take a look at it again. This one, you can wipe out the blues because water vapor does that one. This little area here is unique to CO2. And this little area over here. So when they tell you CO2 is causing all this catastrophic events, it's this little sliver and this little sliver. But most importantly, man produces only 5% of this. So you've got a little pimple here. Man's not even the whitehead on this pimple. It's that little sliver up here at the very top. That's all there is behind this global warming theory behind CO2. Okay? Now, if you take a look at it at 15, if you notice that this one, it cuts off at 15. So I just blew it up, took a look, and sure enough, out there, this is water vapor, and this is CO2. There is an area out there where CO2 is unique. Okay? But once again, man's only producing 5% of this small little area. If you take water vapor and CO2 and overlap it this way, you can see there's only two little areas that are unique to CO2. So this is the whole theory. You ignore all this blue, and these two little yellow spikes is what is man-made cause global warming. And you have to ask yourself, is that a reasonable theory? With all the data, Paul.
You need 5% of that yellow or that
5% of this yellow. Okay? Because you have 100% of the CO2 in the atmosphere. Man produces 5% of the atmospheric CO2. A very small sliver of this. You're talking that little bump here versus this entire spectrum. So as far as the entire absorption, that 5% of this small area is basically negligible for the entire area of infrared absorption.
Who makes the 95%?
Who makes the Mother Nature makes. Mother Nature is a huge producer of CO2. And we're going to get to that.
We're making it happen.
Okay? We're making it right now. The other thing is that the existing CO2, remember there's only that little sliver of infrared anyways. So there's only so much to absorb. According to this research, there's enough CO2 to absorb 100% of it anyways. So by adding more CO2, you can't absorb more than 100%. So if we were to double CO2, according to this research right here says that currently the level of CO2 in the atmosphere absorbs 100% of the infrared radiation by 10 meters to begin with. If you were to double CO2, you would simply reduce the 100% absorption to 9.7 meters. So even if you increase CO2, you can't absorb more than 100% of radiation. If you're already absorbing 100% of it, you can't be causing warming. And the last little part is, what exactly is carbon dioxide anyways? What is carbon? Carbon is the fundamental element of life. Organic chemistry is the study of carbon. Right? Would Mother Nature take an element that is critical to life and make it a poison, to make it a thing that could end this world? I mean, basically, what we're saying is Mother Nature has a built-in doomsday machine where CO2 is going to wipe us all out. And yet carbon is the element, the fundamental element of life. You ever watch Star Trek? What do they say? We're looking for carbon-based life forms. We are all carbon-based life forms. Exhaling CO2.
Can you say, originally when one-celled animals were producing oxygen, wasn't that a poison until oxygen-breathing life came along?
Well, CO2 is a poison.
I know.
At a certain level, sure.
But evolution transforms these toxins into advantages to the next level of evolution.
Sure, and you can have, I believe you can have, some forms of life are based on nitrogen. So you can't have other forms, but for most of life on Earth, it's carbon-based. When we go to Mars and look for life, what are we looking for? Water and carbon, right? Okay, you need carbon. I mean, CO2 is airborne fertilizer, it's plant food. Without it, we die. We die because the plants will die. This part is what I call the smoking guns. These are the charts that I found most interesting, and that do the best to make my case that there's another story that's not being told. Okay? I moved this one right up front. Who saw this in the newspaper just yesterday? California-sized ice melt in Antarctica, right? How many times do you see these glaciers down in Antarctica melting? And what are they blaming on? Global warming. If I read this newspaper, if you go get the newspaper tomorrow, they're going to say, there's a California-sized ice sheet melting in Antarctica, and you're supposed to be jumping, oh my gosh, we got to do something. We got to stop this thing, right? We can't be losing California-sized chunks of ice, right? That's what I'm thinking. That's what it says, and this is in the newspaper just today. You go, you get an infrared chart, and sure enough, lo and behold, you're not kidding, Antarctica is warming. Does anyone see any problem with this chart, though? Global warming is global. What do you see warming here? Specific areas, right? Is the atmosphere doing this? I mean, does it suddenly get warm here and cool over here? Or what's going on there? They forget to tell you that Antarctica is on a fault. There's a bunch of volcanoes down there, all right? And if you go to the USGA Geological Survey, you'll find out that two of the major ones, this Mount Erebus, is right exactly where all that warming is going on. And you go up here, you know how you had that Larsen B shelf melt? Well, lo and behold, it happens to be on what? Two active volcanoes. Did anyone know that in this room? No. I didn't know that until just yesterday. And I started looking into it, and that's what really surprises me about this global warming theory is every time something pops up and I go look into it, they tell a great story, but when you dig underneath it, there's a lot of stuff they forget to tell you. And this is what I just find fascinating. I mean, how can you not tell people that it's on top of an active volcano? Well, someone does. They'll go and they'll check with some researcher. And that researcher will tell you, and I love this one, Arctic volcano not melting ice. Can anyone explain to me how an Arctic volcano cannot melt ice? It's ridiculous.
Why would they say that?
Oh, you can go read it. He basically says that they're not big enough. So just by coincidence, the area where the volcanoes are is warming and melting, but it's not being caused by the volcano.
Are they active?
Yes. Okay. Right here, this is from the Larsen B. Okay. Now this is supposedly once again settled science. Okay. Scientists discovered undersea volcano off Antarctica. When they were going in there trying to figure out what was causing the Larsen B shelf to melt, they went out and they started looking. And they discovered an active volcano under the thing. Did anyone know that? No. That's what I always find so surprising. That's the kind of information I would want to know before I got all panicky about seeing this Larsen B shelf break off. Okay? So doing a little bit more research. Once again, I gave Paula this CD saying there's a website out there you can say it's not global warming, it's ocean warming. And he goes through and he documents all of this. And you can see down here at the bottom one, underground volcanic activity in the Arctic Ocean is far stronger than anyone imagined. Okay? The research is out there, but since it doesn't work into conventional wisdom, why would you publicize this? If you're going to do a story on global warming, Are you going to do it that, by the way, the volcano's melting it, or are you going to say make it look like the climate's melting it? Of course you're going to make it sound like the climate's melting it. Volcano melting, it's a natural thing and it doesn't sell any newspapers. If you really dig into the research, you'll go down there and you'll see that whenever they label these things, they know about it. Melt fissure from hot water from volcano. So if you do your research and dig into it, they know about it. They point it out. Okay? This is on the Ross ice shelf. Okay? And this is just one of the graphics that I showed that shows you that they know when they do label these things that the volcano is melting. This is the other thing I found interesting. And they're always showing Antarctica melting. Well, Antarctica literally doubles in the size of winter. Did anyone know that? The natural change of Antarctica is to double in the winter and shrink back in the summer. It doubles every year. Yes.
Well, actually, the amount of ice that from every winter actually has been reducing over the last close to 100 years now.
Sure, and that would be consistent with the warmer ocean. But I agree. But my point is, seeing these giant ice shelves break off, the thing doubles every year. That's not amazing to see Antarctica losing. I mean, this is probably Southern California right here. It creates it and destroys it every single year.
That was actually shown in NYC with the penguins and chocolate.
You what, did it?
Quite extensive.
Yeah. I didn't see the inconvenient truth, though. This is the North Pole.
Wasn't it that?
Yeah. This is the North Pole. This is what's even more amazing to me. This is the ice area in millions of square kilometers. It goes from 5 to 15. It triples every winter. So when they're talking about the melting of the North Pole, it does it every single year. It triples and then shrinks, triples and shrinks.
But it's shrinking to a smaller and smaller size.
One area is. But once again, it's consistent with the oceans, not the atmosphere.
I mean, that doesn't explain why. I mean, the East River used to freeze every year in New York.
Yeah.
To go back over 100 years, and that has not happened in a very long time.
Sure. That was called the Little Ice Age. And we'll get to that. Okay? This is another thing. You know, they're showing Antarctica melting. Does anyone ever bother to take a look at the temperatures down in Antarctica? They never get anywhere close to zero. You know? It's sub-zero. That's why it's all ice. Okay? So when they're talking about these things melting because of global warming, the atmosphere down there is extremely cold. That's why it's always the snow. It's below freezing. This is the North Pole. Every once in a while, it does annually get near zero. Okay? But it's kind of hard to argue that global warming is causing the melting when the atmosphere never gets anywhere near zero. I don't think ice melts unless you get above 0 degrees. And it looks to me like the warmest it gets is minus 30. Okay? Yeah. Well, this is something you might have seen. This is Republican Joe Barton versus Al Gore. Recently, Al Gore appeared in front of Congress to give his presentation. And Mr. Barton points out, on this point, Mr. Vice President, you're not just off a little, you're totally wrong. Right? Now, why in the world would someone get there in front of C-SPAN, in front of the entire world, and make a claim like that, unless he had something to back it? And he points out, in your movie, you display a timeline of temperature and compare it to CO2 levels over a 600,000 year period, reconstructed from ice core samples. You indicated that this is conclusive proof and link of increase and the link between increased CO2 emissions and global warming. Okay, Al Gore, if you ever watch his movie, he shows you CO2, a chart of CO2 and temperatures. And he claims that the CO2 is causing the temperature to increase. Does anyone disagree with that?
Yeah, because it leads it instead of lagging.
We're going to get there.
Okay.
You're not allowed to answer any more questions. Right? You're stealing my show. Would anyone disagree with that Al Gore shows CO2, and he implies that the CO2 causes the temperature increase? Now, anytime you've had basic science, you learn about the independent and dependent variable. Well, the key is, anytime you do a time series study, the cause has to lead the effect, right? I have to drink a fifth of vodka, then I get drunk. It doesn't make sense for me to claim drinking that vodka caused me to get drunk unless I drank it first. Now, if I get drunk today and drink it tomorrow, it doesn't make any sense. Okay? So the key is the cause has to lead the effect.
Who's Al Gore working for?
Probably himself,
No,
I think. I don't know.
no, because someone's feeding him the info.
Who, Al Gore?
Yeah.
Oh, Lonnie Thompson. Have you seen his movie?
Yeah, I did.
Yeah, Lonnie Thompson. I mean, if you go to Ohio State, they've got this all wrapped up.
Are you Columbus, Ohio, Columbus, Georgia?
Ohio. And so I've been giving this around Ohio State. And every time I give it in Columbus, I invite the Bird Poll Research Center to come and ask questions like you're asking. Well, let's take a look at the chart. Right? This is their chart. This comes from Bostock. This is ice core samples from down in Antarctica. And sure enough, you have a CO2 chart and a temperature chart. Right? And when they show this thing, it looks pretty convincing. Up, up, down, down, and it looks pretty well correlated. The problem is the timeline. And what I did was I took this period right here and I blew it up so you can see what I'm talking about. CO2 is at a very peak level, absolute record high. Temperature, though, if you look at temperature down here, falls to the floor. So previous periods when CO2 was at a record high, temperatures fell through the floor. And if you do a correlation study, what you find is that temperature leads CO2 by about 800 years, meaning that temperature heats up the Earth, and then things start to grow, and then CO2 goes higher, not vice versa. CO2 does not cause higher temperatures, temperature causes higher CO2. And that's what I was always taught until this global warming theory comes around. Things start to grow, then they produce CO2. Okay? Their own chart shows that. Al Gore doesn't get that detailed on it, okay? But that's what Joe Barton is talking about when he says it. This is also well known. This comes from one of the blogs where they debate about this. Okay? And he says, thanks for taking the time to refute and show some points. I still have a problem with the CO2 lags temperature rebuttal of the Real Climate. Real Climate is a website where the real climate scientists debate this stuff. And this guy's gone there and he read their explanation, which you can do. It's a pretty weak explanation, but he points out he points out simply it seems to be incredibly lame. Okay? If you go there, you can read how a global warming scientist would explain this, and it doesn't pass the stink test, is what I say. Okay? Their data just simply doesn't prove or support what they're claiming. Here's another problem they've got. This comes from Al Gore's actual book. I asked this question to Lori Davis when she was at Ohio State, and she didn't like it one bit. Okay? But if you take a look here, you've got CO2 and temperature. This is that scene when Al Gore gets in that crane and he goes up there and he's pointing at, this is CO2, this is CO2. It's record highs, right? You're supposed to be scared to death. But the problem he did was he forgot to mention that there's a temperature chart below it. When he's pointing out record high CO2, his temperatures are actually falling. More importantly, he has previous peaks in temperature at much lower CO2 levels. Here's peak 1, higher than the current level. Peak 2, higher than the current level. Peak 3, higher than the current level. Peak 4, higher than the current level. And peak 5 is higher than the current level. So all the previous peaks on Al Gore's own chart shows that temperatures are below that level that we currently are, and yet his own CO2 chart shows that we're at record highs. One other interesting thing, I'm just going to throw it in for you to think about. They get these temperature charts from ice cores. Does anyone see a problem with using ice cores as a method of measuring temperature? It stops recording at 32, right? And that possibly is the reason why you see these sharp spikes and drops. Normally, you would see all of a sudden hits a certain temperature and then there'd be a gap in the chart because you evaporated or you melted it. There are no gaps in this chart, meaning that over the last 650,000 years, there have been no warming periods in the Antarctica that got above 32 degrees or slowed the warming, or dry periods which would have basically evaporated or evaporated the glaciers.
Or if it did, we wouldn't know about it because it wouldn't be in the
Bingo. A great example is with Kilimanjaro right now. Kilimanjaro has just melted down, and then they got the El Nino new snow. So you have 10,000-year-old snow, and then you have fresh snow. If you're charting it like that, you would have a gap between 10,000 years ago and today. You see that happening today in a glacier. There are no gaps in this chart. That's the first thing I'd start to say. There's a little problem with this data. Okay? This is just a zooming in most recent there. We're below the most recent major peak, and we're below the peak, what's called the medieval warming period, even according to Al Gore's own chart. The other thing is when you create a model like this, you got to have good data. I mean, you have to have consistent, good data. One thing I used to do is I used to be a portfolio manager. I used to run a lot of these multivariable models. And if I was modeling the S&P 500, I'd need to have pretty accurate data for the S&P 500. Right? If I accidentally use the NASDAQ instead of the S&P 500, my model's going to be way off. Well, Al Gore in his own movie has two different charts for temperature. Here's one chart he shows for temperature, which is a giant spike. And then he shows another chart with it falling. So Al Gore in his own movie uses various temperature charts. Okay? It's not good science if someone says, well, temperatures are warming, and you say, according to what chart, right? You'd think they'd have a unified approach or unified theory on temperature. Well, lo and behold, they don't. This is the chart in the 1996 IPCC report. Now, we all were taught that the Vikings inhabited Greenland, right? We all know the Vikings had farms up there, right? According to this chart, they did. We all know, as you pointed out, during the Little Ice Age, while we found Valley Forge, Washington crossed the Delaware that was covered in ice. That doesn't happen today. Right? That was the Little Ice Age. So this chart is historically correct. You can go back and say, yeah, Vikings did inhabit Greenland. We did have the Little Ice Age, a lot of starvation in Europe. Delaware did freeze.
Well, a lot of that pre-industrial age.
Sure.
You know, before you had such an increase in CO2 emissions.
Yeah. Well, my point is that this is what was shown in 1996. The problem is, it doesn't make the case for man-made global warming. So what did they do? They replaced the chart in the 2001 chart. This is what's called the famous hockey stick chart. It denies the medieval warming period, and it denies the Little Ice Age, but this is the chart that they refer to. This is the chart Al Gore will use. Okay? Once again, this seems to be a more accurate chart, but they need this to make their case that man is causing global warming. Now you sit there and think, okay, if you're going to bet the farm and go with this thing, we know that they have a new IPCC report out, right? And if they're settled on this data, and this is if there's a consensus on this from science, don't you think they'd keep the same chart? Well, they don't. Oops, where'd it go? Oh, let me go a little bit further into the hockey stick chart. This is the hockey stick chart. Just to give you a little bit feel how they created this thing. Okay. I point out here that the thermometer was invented back in 1714. So don't you think they'd be using thermometer data since 1714 to create a temperature chart? I would. If you had choices to take tree rings to get your temperature data, coral, ice cores, or a thermometer, what would you use? I would use a thermometer personally. They don't. All the way up to 1980, they're using tree rings and coral rings, okay, and ice cores. Okay? Only when they drop those proxies does temperature shoot up. Okay? So during this period, 1000 to 1980, they used all these proxies, and then from 1902 to 1988, they used the thermometer. They overlap them for the most period, but once they drop the proxies, the temperature shoots up.
Well,
that to me is very questionable.
If your thermometer was invented in 1714, that's still like, you're starting there from the year 1000. So that goes back quite a bit.
Oh, sure, but would you be using tree rings and coral rings up to 1980? Don't you think you'd have a more accurate measurement?
Well, actually, you know, they do know how plants and coral actually react to certain temperatures. So
Sure.
That's a pretty accurate form of, measuring temperature change.
I personally, I would use a thermometer. I mean,
the New York Times would probably be a good approach.
Yeah.
Just go back to the library.
Yeah, there's plenty of ways to get a much better measurement. The key is the data behaves differently once you drop them. All I'm saying is that would make me suspicious. I'm not making any claim.
It behaves differently, but maybe it's because there's a real change.
Okay, the other thing is it mentions Northern Hemisphere. All of this data comes from the Northern Hemisphere. They claim it's global warming, but what you find is that the Southern Hemisphere is actually stable or actually cooling. So you don't have global warming, you have Northern Hemisphere warming, which is inconsistent with global warming. Well, this is what happens when you go to the new IPCC chart. This is the new temperature charts, and it doesn't look anything like anything you saw before. So if there is a consensus, it seems to be a pretty weak consensus because they keep changing all their data. More importantly, is why would you change the data unless you had valid criticisms? Al Gore keeps telling me there's no peer-reviewed data out there that's skeptical of this stuff. If they didn't have valid points, why would they drop the temperature chart? Okay? This is my point. They all model this. This is all saying that CO2 causes the temperature change. We all know Y equals mx plus b. We all know how to run a regression. You know how to make these models. They're claiming that this chart, basically a curvilinear chart, can explain both those charts, or either one of them. Okay? It's not a good model. This is very hard to model into either one of those things, and certainly not both.
Can I just ask you a question? You keep
Sure.
talking about CO2. What about carbon monoxide? That is the pollution from cars. CO. Where does that go? What's the effect of that? They measured CO.
You know, I don't even think, we'll get to a global warming potential chart here in a little bit. I don't even think they consider CO a global warming gas, but we'll get to that and we'll find out.
Okay.
It's so,
Is the paint though after?
yeah, I was going to say that one would be so low anyways.
We can get up there.
Yeah,
Oh, I see.
just like methane and things like that.
It's a long time ago.
Oh, I
This is another issue. Okay, remember you have CO2 that has a gradual increase, but temperature swings all over the place. So it's hard to say something that gradually increases is causing something that's so random. But more importantly, this is a chart of temperature, which is the blue line, and this red and the yellow line is CO2. So it's a gradually increasing, this is a logarithmic type of a chart for those who like science, versus almost a random variable. The important thing here is, prior to 1950, you can see that the slope of CO2 is very flat. Okay? After 1950, there's a gap there, you'll see that it becomes very sharp. So this black arrow is the slope of CO2. Now you would think if the slope of CO2 changes, meaning CO2 is rapidly increasing, and it's causing temperature change, wouldn't you think temperature then will rapidly increase also? Okay? Well, here's temperature, and here's the slope prior to 1940, and you can see this is the slope of temperature. Somehow, during a period of rapidly increasing CO2, temperatures actually fell between 1940 and 1980. So for a 40-year period, temperatures fell during rapidly increasing CO2. But once temperatures rebounded, they rebounded at the exact same slope as prior to cooling period. So a rapidly increasing in CO2 did not change the rate of increase in temperature. Once again, if CO2 is causing it, why doesn't the slope of temperature increase change? Just a question.
Are you done with the hockey stick stuff? Because you didn't mention, I know there's time constraints, and two Canadian statisticians demolished that whole...
With a random, yeah. Bottom, yes. I didn't get into it, but yeah, if you just plug in data randomly...
Could you repeat the question?
There's a lot of problems, and I encourage everyone to take a look at the hockey stick chart and just do a Google search for it and look at the arguments for and against it. One of the things was they pointed out that if you just take random data and throw it in a computer, it'll spit out a hockey stick chart almost identical to the temperature chart that they show there. So basically it looks like there's just a random selection of numbers will produce the hockey stick chart. There's a whole bunch of ways to debunk it. I've done my job. Other Canadians have done it. I'm not Canadian, but other scientists have done it. Okay. And here's just another point of mine that when you take a look at the temperature and the CO2 chart, the arguments are pretty weak. Okay. Now remember, those CO2 data comes from ice core. They go and they dig ice core. And once again, you're sitting there thinking, why in the world would you use ice core data when you can just simply go grab a sample of the air and measure the CO2 in it? That's what I would do. Why go through all this proxy type stuff and make everything so complicated? You want to measure the air, go get an air grab sample that's been stored for a couple of years. Well, they did. They've done that. They've gone back and measured, and it's called the chemical method, where they go back and they look at what was the atmospheric CO2, not from an ice core, but from the actual air. That's a novel idea, isn't it? And what you find is that the atmospheric CO2, measured by the chemical method, fits temperature a lot closer than down here, which is the ice core data. This is if you did an air grab sample, a little flash data measure CO2, this is what the CO2 would show. And you can see it's much more consistent. The important thing is,
But how can you go back in time and take the air?
from records, they've been doing it. They have records of CO2 measurements going back to about the early 1800s. Okay? And they just basically go, it's just like a temperature record. They go back and they say, okay, they measured it.
Actually, they found air bubbles in the Antarctic ice that go back even further than that.
They go back 650,000 years.
Right. Well,
Yeah.
I mean, but to answer your question, why would you use the ice? Well, all the air bubbles that are in there actually tell the story of, different temperature changes over 1 million years, 2 million years, and so on and so forth.
Sure, yeah, there's no argument there. But my point is that's a proxy, though. That's an estimate using a proxy.
Is this chart north or south hemisphere?
This is actually from around the world. This is from both North and Southern hemispheres.
It's just a random sampling?
Yeah, they have South America, Europe, and America measurements in this data. The important thing, though, is They're claiming that you're at record high CO2s. You're at record high CO2s if you use air flash sample and tack it on to ice core data. That's what Al Gore did. If you just take direct measurements, you're nowhere near that peak, which was back in 1940. Okay? Which would be or about 45, which would be consistent because we were what? War. Okay? I could imagine a lot of CO2 being pumped in the air back then. Once again, you can go take a look. This data is right here. You can get it off the Glorious, and you can take a look at it yourself. Okay? This is the other problem with the CO2 data. This is ice core data. It stops in 1950, and then they tack on air grab samples. Okay? So it's not even a consistent data source that Al Gore uses. Mauna Loa, ice core. You can't get two dissimilar data sets to combine. Right?
Why did they stop in 1950 with ice core?
Because it takes 50 years for the current level to get down to being ice. There's a firm layer of snow, packs down, traps the ice. It also assumes that air hasn't changed in 50 years. There's no air dissolving through ice or snow, which I don't believe, or I wouldn't buy. Okay? Well, once again, you've been told that the best fit out there is CO2 and temperature. I think I've shown that's not a good argument. If I was to take this graph and erase what it is and go show it to any second grade class and said, look, here's something, and here's something, which two are closest related? How many people out there would say this is highly related to that? Anybody at all? I tell you one thing, if a student turned that into me, I'd give him an F. But I'd say these two look pretty highly correlated, meaning they go along together well, right? Well, what do you think these two are? One's temperatures, one's the sun. Doesn't that make sense? As the sun heats and cools, the earth heats and cools. That doesn't strike me as a leap of logic, but they're telling you, ignore the sun. This curvilinear chart is what's mostly related to this basically random variable. Does that strike you as a solid model? It doesn't to me. Okay? I know one thing, if a student turned that into me, I'm giving them a big F.
When did we start to measure the hot and cold of the sun, the heating and cooling of the sun?
They use sunspots, so it goes way back, but this goes back to the 1750.
I see.
The key is not necessarily the time, but the fit of the correlation. And the science behind it, there's the logic behind it. Would a trace gas or the sun be the most likely cause? I'd say probably the sun. Down here, there's actually a formula. It's called this Stefan-Boltzmann formula, and it basically points out that, in other words, the temperature of the Earth only depends upon the surface temperature of the sun, the radius of the sun, and the distance between the Earth and the sun. There's a mathematical calculation for it to tell you how warm you're going to get. Okay? Here are the ice caps. All right? Does it look like a polar ice cap to you? Well, they are. And I'm telling you, things are. It looks to me like these polar ice caps are melting, right? 1996, 97, 97. I'm saying we got a serious problem, right? If this is a polar ice cap and it's melting, don't we have a big problem? Would anyone disagree with me?
Well, it's seasonal, isn't it?
Well, this is Mars. Okay? Mars is also, believe it or not, going through global warming. Okay? Climate change hits Mars. Those are Mars's polar ice caps. They're melting also. And you find the same thing on Pluto. So what you have is you don't have global warming. You have solar system warming. Okay? Once again, the sun is the common thread or the common denominator between all of them. The sun heats up, you'd expect the solar system to warm up. Okay? And I don't think you see many SUVs up on Mars. This gets to the point earlier. Most people don't know that water vapor is the most significant greenhouse gas, responsible for 95% of the greenhouse gas effect, or thereabouts. Did anyone other than you know that, or did they ever tell you that? Okay? This is CO2, and this is what I have a real problem with it. Once again, if you're thinking about modeling something, you look for the most significant variables. I wouldn't sit here and say, you know what, here's our problem. I'd sit there and say, there's something changing water vapor, not CO2, but they focus on CO2, which is, to me, odd. This is just that. This is a chart of temperature. You've got latitude, North Pole, South Pole. You have altitude, and you have temperature. Does that look an awful lot like this? I mean, did I just duplicate the chart? Who wants to take a guess at what this is? We got temperature here. What is this? That's atmospheric water vapor. They're almost identical. Okay? Put them next to each other, I can't even tell them apart. I sometimes get them mixed up. I have to remember this is the temperature one. Okay? Where the water vapor is, the temperature is.
What produces water vapor?
Trees and the oceans. Okay, so when Al Gore tells you to go plant a tree, he's saying basically go produce a water vapor creating greenhouse gas.
Less trees now because of deforestation?
Yes and no. There's a lot more trees. There's fewer acreage. There's more trees. In the northern hemisphere, where the warming's occurred, has a lot more trees, and we're going to get to that.
A lot more trees than they used to be?
Yeah, we're far more dense.
Really?
I'm not sure why.
I wouldn't say something unless I could back it. Trust me on that
How
one.
do we get more trees with the deforestation?
The deforestation, as you're going to see, occurs mostly in the equatorial zone. We're going to get to that.
Okay.
And once again, don't take my word for it. These are the things I found fascinating. I reacted exactly like you. I said, no way. Right? I've done the research for you. All you got to do is go read it.
Well, actually, there are more skills from urban sprawl.
Well, I'm not saying they haven't cut down trees, but there's a lot more trees than there were. And the forests are far more dense than they used to be because we had fire prevention. So there's simply more trees, maybe not more acreage, but far more trees. And we'll get to that. Trees are the major source of water vapor over the land. Oceans are the major source over the oceans. Okay? This is one of the situations where they don't know what they're doing, and they're just writing something. And when a scientist is just writing about what he's thinking, he puts it down and he's not thinking about what he's doing. But this is an example of, when you're talking about a science, you typically look for controls. Right? You want to be able to compare one versus the other one, change something here, and then compare what the change did. And so I was thinking, where can I find a control for an area where you have water vapor and CO2, and then no water vapor? And so I did a little research to try to find that out. Well, guess where it occurs? Down in Antarctica. The ocean comes across, it is very moist air, warm air, and as it goes across Antarctica, it loses all that water vapor in the form of snow, so that by the time you get to the interior of Antarctica, there's no water vapor. And you want to know what happens when you get to the interior of Antarctica? You got some seriously cold temperatures. And you want to know what they point out? Say, the extreme dryness of the air caused any heat that is radiated back from the atmosphere to be lost instead of being absorbed by the water vapor in the atmosphere. So when they aren't making a case for CO2 or global warming, they'll tell you it's water vapor. Right there it is. You can go check it out yourself. They say the reason it's so cold in the interior of Antarctica is because there's no water vapor. There's CO2 there, but there's no water vapor. That's why the temperatures plummet. They'll even tell you that. Okay? The other problem they have is you've got parallel warming over both the oceans and land. Global warming doesn't heat the oceans. Infrared is absorbed in the very top layer of the ocean, a millimeter thick. Okay? The sun, the other parts of the spectrum, warm the lower oceans, and according to their own charts, they show the oceans are warming. And heat rises, it doesn't fall. So you'd have to sit there and think, you know what? You've either got two phenomena going on. Something's heating the oceans, and something else is heating the atmosphere, or the same thing that's heating the oceans are heating the atmosphere. I'd be willing to bet it's the later. Okay? Because once again, global warming doesn't impact, especially the deep oceans. Virtually 100% of the heat flow into the oceans is from solar radiation. Okay? And once again, the IR is absorbed in the top. It's called microlayer.
Who said that? Who's quoted that?
I don't know. You have to get the city. You can go do a quote. It's all over the internet. But all you got to do is take this quote, Google it, and it'll pop it up. Or maybe be linked in the presentation.
Actually, what they're finding right now is that there's a huge increase in CO2 in the water, actually preventing any heat being released from the oceans. In fact, that's been shown, over the last 20 years. CO2 is being trapped in the oceans. In fact, they've been charting that with the rising dead zones throughout the northern hemisphere.
I haven't heard anything about that. That would be a totally different phenomenon from global greenhouse gas effect, though. That's trapping the infrared. Whereas the oceans...
It's trapping the CO2 in the things.
Yeah, but once again, the infrared doesn't penetrate the oceans. It would have to be a different phenomenon. Okay? Once again, this is just, I want to show you the CO2 cycle, and what I want you to see here is since 1960, it's gone from 320 to 380, an increase of 60 parts per million. Now remember that number, and we're actually going to get to what you're talking about. See that? Oops. Okay, 60 parts per million, increase in CO2. Okay? The ocean temperature has been increased by about 1 degree from 1960, about 1 degree. Okay? So we have the ocean increased by 1 degree, we have CO2 increased by 60 parts per million. There's something called Henry's Law. It's the diffusion of a gas in a liquid. And lo and behold, someone's done the calculation. How much CO2 would you expect to be released from the ocean if you heated it by 1 degree? It comes out to be 59.1. It's Henry's Law. It's like taking a pop bottle, putting it on a burner, and you see the CO2 shoot out of it. Take anyone with a pop in here, shake it up, you'll see CO2 flies out of it. There's a constant that just explains the diffusion of a gas in a liquid, and it's inversely related to heat. As you heat a liquid, the diffusion of a gas goes down, so it releases it. Almost to the T. Okay? So that's what's actually, I mean, that's what I would say is going on. The sun heats the ocean warms up, and it releases CO2. It's a natural cycle.
Why is the sun only heating the ocean in the northern hemisphere?
We're going to get to that.
Okay.
That's the question you want to ask, though. Because why is only the northern hemisphere warming if it's global warming? What's going on? You'd have to ask what's different between the northern hemisphere and the southern hemisphere. Okay. Very good question, though. This is this carbon. I just want you to understand how what we're dealing with here. Man produces 5 gigatons. 5. Okay? The oceans alone, with their normal exchanges, is over 20 plus times that. 100 to 115. This is a drop in the bucket. The normal variations of the oceans alone are 3 times what man produces. Just the normal variation. Trees breathing. How many people knew trees produce CO2? Well, that's oxygen. Respiration. Trees respire. They produce CO2. 40 to 50. 10 trees breathing and rotting and decaying produce 10 times more CO2 than man does. Man's a drop in the bucket.
I thought they produce oxygen, trees.
They do. They also produce CO2.
And CO2.
Yeah. In the wintertime, they have no leaves, right?
Right.
But they still live, so they have to breathe. Okay? This is Mother Nature when she gets angry. When she produces CO2, she produces a lot. Okay? You can just read through this and you can see that when Mother Nature gets angry, she produces more CO2, nitrous oxide, than you could ever shake a stick at. You could take it and build a football field 600 miles high. I'm willing to bet you could stack every utility plant ever built on top of each other. It's not going to reach 600 miles high. And this is one volcano, for gosh sakes. Okay? One volcano produced a year without a summer. Okay? Now, when we're talking about the thermometer, right, you start to think about, well, when you do a study, Paul, I'm going to probably run out of time because of all the questions, but when you think about thermometers, you sit there and say, okay, well, why don't we go find the longest track record, a continual track record of the thermometer data in the northern hemisphere? That's what I would do. Well, you go to Albany, New York, right here in New York. The longest continual track record of a thermometer measurement of temperature comes from Albany, New York. You know what you find? In 1822, it's 49.2. In 2005, it was 49.2. And you're saying, wait a minute, Internet Skeptic, you're cherry-picking data. You're doggone right I did. Okay? But I'm not going to stop there. I go and I download all the data and I run a regression on it. What do you think you get? You get a negative slope. Temperatures on average, according to the longest continual track record in the northern hemisphere, Albany, New York, shows that temperatures have actually fallen over the last 150 years plus. Don't take my word for it. Do the data yourself.
Well, the last 5 hottest years have been within the last 10.
Sure. This is in the last 10.
Well, yeah, but I mean, this is...
That's my whole point. According to what chart? I can show you the actual data doesn't support that claim. That's why I'm saying it's such a bad theory, because you shouldn't be able to say according to whose data to say, okay, I justify it. This is the most accurate stuff you can get. Here we're going to take a look at what NASA says. Right? Let's take a look at what NASA says. NASA says, this is back in 1997, okay? Recently, much scientific debate has focused on the global temperatures of the Earth's lower atmosphere, the lower atmosphere, as measured by orbiting satellite. Now, remember, this is NASA. These are rocket scientists. These are people who don't play around, okay? And they're not going to use ice cores and coral rings to get their temperature measurements. They go bring out the satellites. Okay? And while these data are exceedingly precise, verified by multiple satellite observations, they go back and double, triple, quadruple check the data, and balloon measurements taken in situ, they reveal no discernible warming trend in the Earth's lower atmosphere over the last 18 plus years. Now remember that one chart I showed you showed cooling between 1940 and 1980. Going back 18 plus years here, that shows you that you've had no warming since 1940, according to NASA's in their own charts, that other chart that I showed you. So if you combine those two, you haven't had the warmest periods. Okay? It all depends on who you're talking to. NASA disagrees. This is what they're talking about. You have three different measurements. You got balloon, you got satellite, and you got ground measurements. Ground measurements are impacted by the urban effect. Okay? Cities and roads trap heat. Well, sure enough, if you do measurements that way, if you take a temperature measurement on a hot roof, tar roof, or off a highway, it's hot. Okay? Satellites don't show it. So out of the three measurements, if you have three ways to measure temperature, two of them confirm and one doesn't, wouldn't normal scientists go with the two confirming measurements instead of the one that's non-confirmed? But they don't. In order to make their case, they go with the non-confirmed measurement. And the one that is known to be impacted by the urban effect. Okay, does everyone know what a global warming potential is? Global warming potential is when they create these models, they assign something called a global warming potential. And it shows you how significant or how much heat is trapped by a greenhouse gas relative to carbon dioxide. So carbon dioxide is one, and all other greenhouse gases are measured relative to it. Okay? You want to have some fun? Try to find out what the global warming potential of water vapor is. If I was going to have a model and I had a factor that is key to my model, wouldn't I want to assign a global warming potential of water vapor? It doesn't exist. More importantly, part of this model has what's called a residency life in it. Okay? It's how long the greenhouse gas has been in the atmosphere is important.
Now, one second, we're just changing tapes. Thanks.
Do I have to back up at all?
No, just that how important it is.
Great question, by the way.
While we're between states, I read that they closed a lot of the temperature stations in Russia and the Soviet Union.